Hello again, grade 7s, and welcome to the final lesson in Community Math 7, where we are going to deal with a slightly more difficult algebraic equation, referred to as a two-step equation. Two-step equation because there's going to be a couple of operations we're going to need to use to properly isolate the equation. Learning outcome is to model and solve concretely, pictorially, and symbolically problems that can be represented by linear equations in the form ax plus b equals c, where a, b, and c are whole numbers. Okay, the problem with these equations is we're starting to now get to a stage where inspection is becoming difficult to use. So inspection, again, is the method where you can use guess and test. And for these equations, actually, you probably still could use guess and test to do them, but it's just a little bit harder in comparison to the one-step equations. What we want to do is we want to use just the isolation technique. The thing is, we're going to have a couple of different operations we need to use. And in terms of like which operation we do first, we need to use the reverse order of operations. So you'll recall that when we complete an operation, the normal order of operations is the acronym BEDMAS, brackets, exponents, division, multiplication, whatever comes first, addition, subtraction, whatever comes first. And if you flip that around, we would do subtraction and addition first, multiplication and division second, and deal with brackets at the very end. So step one is we're going to take care of the addition and subtraction first, okay, because it comes first in the reverse order of operations. And then step two is we're going to take care of the multiplication and division second, because it comes second in the reverse order of operations. However, before we do that, we are once again going to torture ourselves by modeling and solving this with cups and counters and algebra tiles. And then we're going to worry just about the isolation method afterwards. Okay, so it says model the following equations and then solve them. So we have 3w plus 3 is equal to 6. Okay, so the numerical coefficient is 3, which means that we're going to draw 3 cups. So I'm going to do 1, 2, 3 cups. And then for cups and counters, we show the operator, which is a plus sign. So we add 3. So 1, 2, 3. And that would be equal to 1, 2, 3, 4, 5, 6. Okay, so we got 3 cups. 3w plus 3 is equal to 6. Now, what we want to do is it's a little more complicated because now we have 3 cups. So the question we want to ask ourselves is, how many counters would need to be placed in each of these cups in each cup to balance the equation. Okay, now I'll do this in a different color. Okay, so we don't know how much goes into each cup. Okay, so here's what we know. We have 3 mystery cups, but we also have 3 counters on this left-hand side. So whatever's in the mystery cups, they have to add up to 3 to give you the right side of the equation. So what plus 3 would be equal to 6? Well, it'd be 3. So I know in total, I'm going to have to put 3 counters into all 3 of these cups. But it's asking me how much goes into each one cup. So to balance this, what I would do is I'd have to drop 1 counter into this cup, 1 counter into that one, 1 into this one. Okay, so I took my 3 counters and I divided them evenly by the 3 cups. So that's the solution to the equation. It's how many counters would need to be placed in each cup. So it'd be 1 counter in each cup. Therefore, what's the solution to the equation? Well, the variable is W. W represents a mystery cup. So how many counters do you have to put into each mystery cup for this to work? Put one counter into each cup. If I put one counter into each cup, I'd have 3 total. Add another 3. That would give me 6 counters at the end. Okay, second one, we're going to use algebra tiles. So 2p plus 4 is equal to 10. So we represent the numerical coefficient with rectangles. So I have one rectangle here, which I'm going to put a p inside. And then another rectangle, which I'm also going to put the letter p inside. Okay, this is a positive constant. Positive constant, we use red squares to represent. So we have 4 of them. So 1, 2, 3, 4. And then on the right-hand side, we also have a positive constant of 10s. That's going to be 10 of these red squares. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so this time around, the question I want to ask is instead of cups, I have these rectangles. So I'd ask myself, how many red squares would need to be placed in each mystery rectangle, and each of them in each rectangle to balance the equation. Okay, so let's think about this. Okay, so the right-hand side has 10 squares. However many red squares are going to be inside the mystery rectangles, we're going to have to combine them with these 4. So basically, we're going to have to take the total number of my red squares in the rectangles, add them up with 4, and that needs to be equal to 10. So how many rectangles need to be shared between these 2 rectangles? How many of the squares need to be shared between the 2 rectangles? It should be 6 of them. Because we have 6 red squares shared between the rectangles, add another 4, we would then have 10 total. Okay. Now, you have to share the 6 red squares between both of these rectangles. So what we're going to do is we're going to put 3 red squares into each one of them. So we'll do 1, 2, 3. 1, 2, 3. Okay, so we're putting 3 red squares into each rectangle. So let's say 3 red squares into each rectangle. Therefore, okay, we'd say P, the variable, would be equal to the number of squares you put in there. So you put 3 red squares in there, so that'd be P is equal to 3. Okay, so that's it for cups and counters and algebra tiles. I'm not going to worry about it anymore. Now, what we're mainly interested in is we're interested in using the reverse order of operations or the isolation method. Okay, so I'm going to do a C and D here as well, just to kind of do a bit more in a moment. All right. we need to get we need to get n isolated. Okay, so let's just highlight the n. We've got to get it isolated. Now, there are two reasons that the n is not isolated right now. Okay, it's being multiplied by 5 and it's being added to 7. So the question is, well, what do you do first? Do you try to take care of the 5 first because it's being multiplied, or you take care of the 7 first because it's being added? Well, we use the reverse order of operations. So my again, regular order of operations would be BEDMAS. The reverse order of operations would be SAM, D, E, S, which means we deal with subtraction and addition first. We're going to deal with the 7 first. Okay, so how do we get rid of the 7? Apply the opposite operation. What's the opposite operation of addition? Subtraction. So we're going to subtract 7. Okay, so we're going to bring the 5n down. And then plus 7 and negative 5 would just be 0. That gets rid of the 7 on that side. And whatever we do to one side, got to do to the other. So we've got to add 7 to this side. Sorry, not add 7, subtract 7 from this side as well. Okay, 32 minus 7 would be 25. Okay, let's clean this up a little bit because we don't need to write 5n plus 0. We can simply write down 5n is equal to 25. Okay, now all we have to do to get n by itself is get rid of this 5. So how do we get rid of the 5? Well, right now it's being attached to the n through multiplication. So the opposite operation of multiplication is going to be division. So we're going to divide both sides of the equation by 5. Divide by 5. What this is going to do is this is going to get rid of the 5 on the top and the 5 on the bottom. So we can just cross them off. And that would leave me with, you're just left with n now. And 25 divided by 5 would just be equal to 5. So the solution to the equation is 5. Okay, B, 53 equals 4r minus 11. Okay, so like I said, like the guess and test method is starting to become like really difficult to use at this stage. This is where we want to rely on the isolation method. Okay, so let's look at this. So we have 53 is 4r minus 11. I want to get the r by itself. Okay, why isn't the r isolated right now? Because it's being multiplied by 4 and subtraction of 11. So which one do we deal with first? The multiplication or the subtraction? But look at the reverse order of operations. We're going to deal with the subtraction addition always first. Okay, so we got to get rid of this negative 11. What's the opposite operation of minus? Plus. So we're going to add 11 to both sides of the equation. 53 plus 11 would be 64. Let's carry the 4r down. This would be 4r plus 0. Let's rewrite this out. We don't need to write down the 0. We can just write down 64 is equal to 4r. Okay, how do we get this r isolated now? Well, it's being multiplied by the variable. So the opposite operation of multiplication is division. So we're going to divide both sides of the equation by 4. Divide 4, divide 4. 64 divided by 4 is 16. And then 4 divided by 4 is 1. So you're just left with 1r or r. However, when we write down an answer, usually we like to write the variable first. We write down r would then be equal to 16. Okay, let's do another one. I'm going to write down, let's do, how about 2k minus 20 is equal to, we'll do negative 10. 2k minus 20 is equal to negative 10. Okay, so why isn't the k isolated? Because it's being multiplied by 2 and it's also being subtracted by 20. Okay, so which one do we do first? Reverse order of operations. Always do the subtraction addition first. How do we get rid of this subtraction of 20? We're going to apply the opposite operation, which is going to be add 20. And whatever I add to one side, I need to add to the other side. Okay, let's carry the 2k down. 2k comes down. Negative 20 and 20 would give you 0. And then negative 10 plus 20 would mean, well, think about this. If you're on a number line and you were at negative 20 and you went to the right by 20, you would actually end up at positive 20. So positive 10. Yeah, if it was like negative 10 degrees Celsius outside and we had a temperature increase of 20 degrees, we'd then be at positive 10 degrees Celsius. Okay, so I have 2K plus 0 is 10. So this would then be 2K is 10. Don't need to show the 0. And now I got to get the K by itself. So right now it's being multiplied by 2. How do I get rid of that 2? Opposite operation is division. So divide by 2, divide by 2. Cancels, cancels. 2 over 2 is 1, which would give you 1K, which I can just write down as K. We don't need to show the numerical coefficient of 1. And then 10 divided by 2 would just be 5. Okay, and let's do one more. So let's do something along the lines of, how about 3t? And let's do plus, I don't know, 3t plus 6 is equal to, I'll do 24. Okay, so got to do 2 steps here. So first things first, why is the t not isolated? Because it's being added to 6 and it's also being multiplied by 3. So what do I do first? Multiplication or the multiplication or the addition? Well, the addition. Look at the reverse order operations. Do subtraction, addition first, multiplication, and division second. So how do I get rid of plus 6? Apply the opposite operation, which is minus. So you're going to subtract 6 from this side. Whatever you do to one side, got to do the other side as well. So I'm also going to subtract 6 from that side of the equation. Carry this down. So this would then be 3t plus 0 is equal to 24 minus 6 is 18. Let's rewrite this out. So we don't need to show that 0. It would just be 3t is equal to 18. Get the t by itself. So right now it's being multiplied by 3. So we're going to apply the opposite operation of division to get rid of it. 3 divided by 3 would just cancel off to leave you with 1t or t. And then 18 divided by 3 would be equal to 6. Okay, so very important that we understand how to use this isolation or apply the opposite operation technique, okay? These are still, like, comparatively speaking, like equations we deal with in like physics 20 or 30. These are like pretty simple equations, but it's all right now about just getting that building, the building blocks, or that nice solid base of mathematical algebra foundations so that we can deal with more complicated equations later. Okay, so that's it for this lesson and for the course in terms of like content. And you can complete page 412, numbers 7, 11, 12, and 13.